All right, so last time we looked at multiplying polynomials. We did monomials times polynomials, where we used the distributive property. We did binomials times binomials, where we used the FOIL method. And now we're going to look at polynomials with 2 or more terms times polynomials with 3 or more terms. So no matter what, in our examples, you're going to see at least a binomial and a trinomial multiplied by each other. But this works for trinomials times trinomials. It could work for 5 terms or 6 terms, anything. You can also use these methods on the lower ones, like monomials times polynomials, binomials times binomials, but they have their own methods, so we went through those first. Now these methods will encompass any polynomials that you multiply. So the first one is our box method, and this is a visual way of organizing this multiplication. I like to start with our highest order polynomial. So which one is that? Right, it's going to be 6x squared plus 4x plus 3 because we have a 6x squared as our leading term here. And in our first one, we have 2x as our leading term. So the first one's linear and the second's quadratic. We'll go with the quadratic. So I like to do that one first, and what I'm going to do is write each term a little spread out from each other. And just to keep everything organized, this one, it's not as important because you see there's all positive signs, but I like to put whether it's positive or negative with each number. So now that I did that for one of my polynomials, my second polynomial, I'm going to put on the side. And I just told you it's called the box method. As you can see, we're about to make a box. And let me write box method. The reason that I picked my highest order polynomial first is because I want to leave a space for the terms that we're missing. Do we need to do this? No, but I like to do it because there's a fun little trick that comes up later that if you always leave a space for every term, you'll always see this happen. So I like to do that. This is where our x squared would go, right? We don't have an x squared, so what's our coefficient in front of that if we don't have an x squared? 0, right? So that's like 0x squared. So instead, we're just going to say 0. And then 2x and 4, and that's a plus 2x and a plus 4. So now if it makes you feel better, which I know it does for me, you can draw the lines to make like a table of a box. Let's see. So we have a box, and what we're going to do is just like in when we learned our multiplication tables and we had a grid with all of our multiplication values in it, and we'll see that sometimes when you're looking at the wall in a math classroom. And we're going to do the same thing here. So we're going to start with the easy one. We have a 0 here. So what's 0 times anything? 0. So we know that this whole row is going to be 0 just because it's all being multiplied by 0. So let's do this column right here first. What is 6x squared times 2x? Well, our coefficients are 6 times 2, which is 12. And our variables are x squared times x. So x cubed. right? So we're still in this column, so we're still using 6x squared, and now we're multiplying it by 4. So 6 times 4 is 24. X squared times no other x, so we bring our x squared down. All right, so now we're going to go to this next column, 4x times 2x, 8x squared, 4x times 4, 16x, and now we're going to go to this column. 3 times 2x is 6x, and 3 times 4 is 12. So earlier I mentioned that I like putting this placeholder because there's something that's going to show up that if you have the same terms on the top of the box and the side of the box, this pattern will show up every single time. And what that pattern is if you look at the diagonal, you can see we have like terms. So it already it already grouped our like terms with us, and now all we have to do is combine them. So 24x squared plus 8x, and I'm going to write it down here, is 32x squared. And that's 24x squared plus 8x squared. I forgot to say the squared. I apologize. And so now on this diagonal, we have 16x plus 6x, which is 22x. Right? And those are positive. And then we can see this diagonal and this one, they don't have anything to add, so they're just themselves. And wait, if we look at that, I think we just got our answer. We can condense it down and put them together. 12x cubed plus 32x squared plus 22x plus 12. There's our answer. And I did mention again, so like I like doing this where I put the 0 in when there's a pattern. That might not be exciting if you have like a 10-term polynomial times a 2-term polynomial. So you can actually do it without, where this would be, let me get a color, where this would be gone. And so it's a 3 box times a 2 box. And in this case, it is always on the diagonal, and that works because the highest term's on the top. If you would have done 2x plus 4, and then you had the 6x squared, 4x, and 3 on the side, that would not, the diagonals wouldn't be there. So you just have to make sure before you add up the diagonals that they're actually like terms. If you set it up the way we set it up in our example, the like terms will be there. And then the second method, so that was their box method. The second method is still just the distributive property. So we've only ever looked at the distributive property with one term times a bunch of other terms. But you can also do the distributive property with multiple terms. And actually, when we looked at binomials times binomials, we had a little glimpse into that. It's just we had an easy way to organize it with FOIL. So we're actually going to do the same problem so you can see how it was done. We're going to do the exact same problem. And I'm going to erase this work. Okay, I'm going to do the exact same problem. I'm going to use my orange color. And now we can do the distributive property. So with a little bit of, I'll come back to that. Okay, so we're going to do the distributive property. What we're going to do first, and I like to, for this method, I like to start with our lowest number of terms. So I'm going to pick my 2x first. That's what I'm going to work with first. And I'm just going to do the distributive property how we already know how to do the distributive property. So I'm going to multiply it by each number in our second polynomial. So I'm going to write that a little bit lower. 2x times 6x squared plus 2x times 4x plus 2x times 3. All right, so I got that, but I still have a plus 4. So I'm going to do that now. And I'm going to do the distributive property the exact same way we've always done it. 4 times all of these terms. So 4 times 6x squared plus 4 times 4x plus 4 times 3. All right, so let's get those together now. So 2x times 6x squared, so we have 2 times 6, 12, x cubed, plus 8x squared, plus 6x. And these numbers are starting to look familiar, right? Because we just found those in our box method. So we were doing the exact same problem, the exact same multiplication, we just did it in 2 different ways. So plus 24x squared plus 16x and plus 12. And now we need to group our like terms. So we have x cubed by itself. We have 8x squared and 24x squared. We have 6x and 16x. And then we have 12 by itself. Okay. So now we're going to bring that down here. We'll bring down 12x cubed because he's by himself. And now we have 8x squared and 24x squared, which is 32x squared. We have 6x plus 16x, which is 22x. And we have 12 all by himself. Right? And there's our answer that way. So both of these methods work. It just depends on what comes easier for you when you're organizing and trying to multiply. I like both ways, and both ways are pretty fast. So whichever makes most sense to you, and let's practice.